This is Algebra 2 practice problems for 4.2 solving linear systems algebraically. So the first 6 problems here we're going to be solving using the substitution method. And so we use the substitution method when it is easy to isolate one variable. And it looks like for the first 2 we already have a variable solved for, right? We've got 1y is equal to something for both 1 and 2. Okay, so these ones are going to be kind of easy. If we recognize that we have y is equal to this expression, well, we can pull that out and plug it in for the y in the top equation. Okay, so I'm going to rewrite that out. 5x plus 3y, but y is also equal to negative 3x minus 3. So I'm going to substitute it out there. All right, and then now we're dealing with the same variable, so we can isolate and solve for it. So let's go ahead and distribute here. We've got 9x minus 9. Drop everything else down. Let's combine like terms. 5x minus 9x is negative 4x. And I want to isolate this negative 4x, so let's get rid of this negative 9. Do so by adding 9. And I'm left negative 4x is equal to 8. And now we divide by negative 4 on both sides, and we're left with x is equal to negative 2. Okay, remember we want our answer as an ordered pair, so we need to find our x and our y. So once we solve for one of our variables, we can plug it into either the top or the bottom equation. It doesn't matter. You just want to pick the one that you think is going to be easiest. I think the bottom one will be easier. So let's use that one. Y is equal to negative 3 times x. But now we know x is negative 2 minus 3. So we can just simplify here, and we've got y solved for. Negative 3 times negative 2 is positive 6. Positive 6 minus 3 is 3. All right, so let's write our answer as an ordered pair. Negative 2, comma 3. There's the answer. All right, so number 2 looks pretty straightforward. Y is already solved for. Number 3, we don't have a variable solved for, but because we have this 1x, all we would have to do here is just subtract 8 on both sides. So let's rewrite this as x is equal to negative 8y minus 18. Oops, there we go. Okay, and then we'll just take this expression and plug it into the bottom equation. So I'm going to do negative 6 times negative 8y minus 18 plus 3y is equal to 6. All right, I'll leave this one up to you guys, so go ahead and solve for y, and then again, don't forget to plug it back into one of the original equations and solve for x. All right, 4, 5, and 6 look pretty straightforward. They all have at least one variable solved for, so you can go ahead with those. And 7, 8, 9, 10, 11, and 12, these we're going to use the elimination method. And some of these are easier than others. So for number 7, these are already set up to eliminate the x's because we have negative 7 and positive 7x. So if we add these together, these will eliminate. All right. And if I add up my y's, we get 2y minus 1y. That is going to equal 1y. And 4 minus 2 is 2. So y is already solved for. So now, just plug it into one of the original equations. I think I'm going to use the bottom one. 7x minus y, which is 2, is equal to negative 2. And go ahead and solve. Add 2 on both sides. We're left with 7x is equal to 0. Divide by 7, divide by 7. We're left with x is equal to 0. Okay, let's see. Let's do Number 8's pretty similar. It looks like the x's will eliminate. However, we don't have the y's lined up. So if I wanted to get take the top equation, 4x is equal to 24 plus 2y. I want to get the y on the left hand side, so I need to subtract 2y on both sides. So I would rewrite that as, so I'm going to get rid of this. It's going to be 4x minus 2y is equal to 24. Now you can go ahead and add these together. We'll get the x's canceling out. Negative 6y is equal to 12. Solve for y and then plug back in for x. Okay. Can do pretty much the same thing for 9. Okay, so looks like for 10, we don't have anything we can eliminate right away, so we're going to have to take one or more of the equations and multiply. Okay, so I think the easiest thing to do is take this whole bottom equation and multiply everything by -2. Okay, because then we'll cancel out our x's. So if I distribute here, we have -2x. -2 times -2y is positive 4y. And -2 times -10 is positive 20. All right, now I'm just going to take this bottom equation and rewrite it. 2x plus 3y is equal to -6. These will cancel. 4 plus 3 is 7. Y. 20 minus 6 is 14. Divide by 7. Divide by 7. You're left with y is equal to 2. And let's see, which one should we use? Let's just use the top equation here. 2x plus 3 times 2 is equal to -6. So we get 2x plus 6 is equal to -6. Subtract 6 on both sides. We're left with 2x is equal to -12. Divide by 2, divide by 2. Left with x is equal to -6. So again, make sure you write the answers as an ordered pair, and you're good to go. All right. Number 11 looks fairly similar. Just go ahead and multiply either one of those by, well, you're going to want to multiply the top by +2, and something interesting will happen there. I'll let you figure that one out. Actually, whatever, I'll do it. I'll do this one just to show you guys an example of this. So if I multiply here this top equation by 2, everything by 2, I'm going to be left with 2x plus 2y is equal to 14. Okay, and if I do that, these will all cancel out and equal to 0 and equal 0, and then we get -14 plus 14, so that's equal to 0. And anytime I get something that is identical to itself, that means there's infinitely many solutions. Okay, could also call this identity. Basically, what that means is that any value of x and y will work. Okay. Let's see. For number 12, I would just take one of these equations and multiply it by -2. You should be able to figure out what's going to eliminate there. 13 and 14. Looks like nothing's set up to eliminate. So you got to ask yourself, what's the easiest way to eliminate here? You're going to need to multiply both of these equations by something. So you could either get the x terms equal to 40, because that's the least common multiple, or you get y terms equal to 24, plus and minus. So it's up to you. It's probably easier to do 24. So you would want to multiply the top equation by 4 and the bottom equation by 3. Line them up, they should eliminate the y's. All right, I'll leave 14 up to you. You should be able to figure out, you're going to have to do something similar to 13. All right, 15 and 16, you just have to choose the best method for solving. Yeah, I'll leave these up to you as well. You could use either one. So really, you're just going to be choosing, or you're going to be making it easier on yourself by picking the correct method. Okay, but like I said, it doesn't really matter. You can use either one. All right. Let's see. Is there anything else I should go over? Let's see. 12 and 6, you're going to get a decimal answer, so don't think you got it wrong just because you got a decimal. Everything else, you will get whole numbers. Let's show one more, just as something else unique happens with number 4. So I'll do this one. Oh, at 4, we're doing substitution. So I'm going to plug this in for y. So we get 9x plus 3 times negative 8 minus 3x. There we go. Is equal to negative 4. Go ahead and distribute. We're left with negative 4 minus 9x. Drop everything else down. All right, and you're going to notice the x's. This is a positive 9. The x's are going to eliminate here, right? We got positive 9x, negative 9x, so those will eliminate. And what you're left with is negative 24 is equal to negative 4. Anytime your variable cancels out and you're left with something like this that does not match, that means your answer is no solution. All right, I think I went over enough problems here and went through anything tricky. There is a couple more no solution problems, so keep an eye out for that. And remember, only 2 decimal problems. If you need more help with this, you know where to find me. Good luck.